Now, can anyone tell me what a fraction is? What does it tell us? Why are they useful? Anything about fractions that you know? Boipelo, tell me something.
Hi, ma'am.
Hi.
What I know about a fraction is that it represents a part of a whole.
Excellent. So fractions represent parts or a part of the whole. Now, when I sort of say that, we also need to understand what that means. And so if we sort of imagine this visually for ourselves, imagine that as like a pizza or a pie or whatever floats your boat. If we divide this pizza pie circle up into parts, and you can divide it into however many parts you want, and we start to consider certain sections, we're considering a fraction of the whole. So here I've got 8 pieces and I'm shading 3 out of the 8. And so that fraction is representing specific parts of the whole thing that we are talking about. Like I say, guys, what we're talking about today is fractions. Alrighty. So that is our topic for those of you asking. So fractions represent part of a whole. I don't know if you want to take a screenshot of that. I'll just leave it up there for a second or two in case you do. Right, and then what we're going to have a look at is just some different types of fractions that we can work with. So I want to start with common fractions. I don't know why I didn't put it in, but anywho. Can anyone tell me what a common fraction is? Like, how do I identify a common fraction? Phumzile, what is a common fraction?
Hi, ma'am.
Hi.
Common fraction is where the denominator is larger than the numerator.
Perfect. So guys, common fractions is basically where your numerator is large. Yes, I need to listen. Your numerator is smaller than your denominator. I'm being a bit lazy here with the symbol, so the symbol smaller than. Now, that's all well and good, but obviously we need to understand what numerator and denominator actually mean. So a fraction is made up of 2 parts. We've got a top part and we've got a bottom part. Now, we don't call it the top and the bottom mathematically. There are names for it. The top of our fraction is our numerator, and the bottom part of our fraction is our denominator. So basically, the bottom is bigger than the top in a common fraction. If the bottom is bigger than the top, then you are working with a common fraction. Right, don't stress about screenshotting. I will put all of the definitions all on one screen for you to screenshot just now. Does anyone want to help me and tell me what a mixed number is? Tini, do you want to help us?
Hello, ma'am.
Hi.
A mixed number, a number that is written as a combination of a fraction and a whole number.
Perfect. I like that. It's a combination. So it's a combination of a whole number. I'm going to say integer just because sometimes it can be negative, integer, and a fraction. Right now, there are an infinite number of examples that I could give you here. But say, for example, something like 3 1/4. There's an integer or whole number part of it, and then we've got a fraction part. Mixed numbers are useful when we're working with multiple wholes and then part of a next whole. And so, for example, 3 1/4, if I did like a visual representation of it, it's not going to be a beautiful representation, but we're going to just work with it. We've got 3 wholes and then only one part of the 4 parts of my 4th whole. So it allows us to represent more than a whole, a mixed number. Alrighty, so Becky, I see your hand up. What is an improper fraction?
Afternoon, ma'am.
Hi.
Ma'am, an improper fraction is when the numerator is bigger and the denominator is smaller.
Perfect. So this is now the opposite of a common fraction. Your numerator is now bigger than your denominator. Now once panic. Now once again, improper fractions and mixed numbers allow us to represent more than just a whole. So for example, if we take 2 and, oh yes, sorry guys, maybe just losing my marbles a little bit. If we take 3/2, the numerator is bigger than the denominator. And so again, it's representing more than just the whole. So 3/2 is 1.5. Let's actually also not do that. Let's go like this. I'm having a slight moment of panic for whatever reason. Get in there, sorry. I don't like my picture, and let me just do a better picture, right? 1.5, there's my whole, and then I've got my half. So mixed numbers and improper fractions allow us to represent more than a whole and then a portion of. Okay, so those are our definitions of our different types of fractions. I'm going to do that in case you want to take a screenshot of all of them. I see there's some questions in the chat and some hellos. Gorka, in terms of factors, we did, getting all my grades confused now. We will eventually talk about highest common factors and lowest common factors and prime factors and all of those sorts of things. But we are doing fractions at the moment. But with that being said, highest common factor also comes into thinking about lowest common denominators, which hopefully we're going to get to at some point. If not, next lesson, but the idea is very similar. Right, I'm hoping you've taken your screenshots. I see a lot of questions about what are we doing sort of thing, and I didn't point this out earlier, so I'm just going to point it out now quickly. In this purple block, you will see what course we're currently doing. So we're currently looking at whole numbers and integers, maybe say and integers. And so that is where we're at now. Our upcoming courses are then exponents, number patterns, and then we're going to revise sort of term 1. So when asking about all of those other things, we're going to get to algebra, we're going to get to decimals, all of those things. Right now, this is what we're currently doing. Alrighty. Just in case you haven't got a screenshot, quickly take it. 3, 2, 1, and let's have a look at some examples. Right, so when we start to work with fractions, another very important thing that we need to understand is that fractions can be written, fractions that represent the same parts of a whole don't necessarily all have to be written in the same way. Oh, excuse me, sorry. Right, so equivalent fractions are basically fractions that look different but represent the same portion of the whole. Okay, so when I say they look different, I mean that the numbers in the numerator and denominator are different numbers, but at the end of the day, they represent the same thing. So if we have a look at our pizza slices or our pies or whatever you want to think of these things as, we have got 4 different images, but we can see that the same proportion or the same sort of part is shaded. So if we look at our first fraction, we can see that 1 out of 2 parts are shaded. If we look at our second image, we can see that 2 out of 4 parts are shaded. And so if we keep going, we are getting different fractions, so fractions that look different. But if we look at the picture, actually represent the same portion of the whole. This is half shaded, this is half shaded, and so all of these actually represent the same part of the whole. And the reason for that is because of equivalent fractions. These fractions all mean exactly the same thing. All of these fractions, if I simplify them, are going to give me a half. And so they all represent a half, so half of a whole. And that's essentially, like I say, what an equivalent fraction is. Okay, so as Simtanda said, they're all half of the shape. They're only representing part, but all of those different fractions represent the same thing. Okay, so guys, for screenshots, please make sure you do take your screenshots. I give you time to do it. Do it. I'm quickly going back here in case you need this. Oops. Okay. All right, so let's have a look at working with some equivalent fractions here. So what we want to do is we want to fill in the missing values. Now, what you need to take note of in these examples is the fact that we have an equal sign between these fractions. And because there's an equal sign, it means that we're working with equivalent fractions. They are equal to each other. They represent the same amount. Right, so I'm going to do the first one with you just so that you can see sort of the goal here. But basically what we want to do is we want to figure out what numbers are missing so that all of these fractions represent the same parts of the whole. If we look at 5 and 15, the two denominators that we have, my question to myself should be, what am I timesing 5 by to get 15? Well, I'm timesing it by 3. Now, in order to keep a fraction equivalent, we need to do the same thing in the numerator. So I need to times 4 by 3. And so that gives me the equivalent fraction of 12 over 15. And the same thing can now happen with the third fraction. Now, you can compare this to either the first fraction or the second fraction. It doesn't matter. If we compare to the first one, I know that I need to multiply 4 by 6. In order to get 24. And so I must do the same thing with 5. If I times 5 by 6, I get 30. If you didn't want to use the first fraction, that's cool. We know that to get from 12 to 24, I times by 2. And so I must times 15 by 2. You get exactly the same thing. And that is sort of what equivalent fractions are. Doesn't matter which one you're working with, it represents the same thing. So that's why it's not really, we don't have to stress about whether or not we are working with the 4/5 or the 12/15. Right, so yes, as Mpho said here, this is sort of like the concept of, in order to keep them equal, what I do at the bottom, I have to do at the top, or what I do at the top, I have to do at the bottom. That is so that I'm keeping my fractions equivalent. Very good, well done. Right, guys, so take your screenshot of this. What I'm going to do is I'll make this a touch smaller so that when you try the second one, you sort of know what you're doing. But I'd like you to try B for me. So B, got so much going on the screen. We've got 7 over 8 is equal to 84 over something. So we want that denominator is equal to something over 40. They're all equal, so they're equivalent fractions. Just remember that. So have a try, have a think. If you would like to raise your hand, you know you're more than welcome to. And try and give me those equivalent fractions there. Remember, guys, if you're struggling to see, if the screen's not working, you might need to log out and then log back in again. And if you need to go, we get it for whatever reason. If it's an emergency, load shedding, whatever, you can get the recording. So don't stress. Liz has already got her hand up. Oh, no, Liz left me. All right, I'm going to give you another minute or so, and then I'm going to take some hands. All right, Catherine, do you want to help me with the first fraction?
Yes.
Okay.
You say 7 times 12 equals to 84.
Perfect. So what do we do at the bottom?
Then you say 8 times 12 equals to 96.
Perfect. Well done. Okay, so guys, for the first fraction, we need to multiply by 12 in order to get the equivalent fraction. So Walker, do you want to, I feel like you asked to change your name, but I'm not 100% sure. You can correct me. What is the second one? Okay. Coquetto, do you want to give me the second fraction here?
Okay, ma'am. I have my cousin here. He wants to try it. His
Okay.
name is Pusili.
Okay, ma'am. With my calculations, I'm not sure if it's correct, but what I did was like I took 84 and divided by 7. It gave me 12. And for the last fraction, it will be 12 over 40, I think.
Okay, so I really like the 12 part because that, like you said, that's coming from the 84. But remember now what we want to do is we want to ask ourselves, what am I timesing 8 by to get 40? And 8 times 5 gives us 40. And so we need to then do the same thing with the 7. We need to times 7 by 5. So what's 7 times 5?
Well, 7 times 5 is equals to 35.
Excellent, well done. And so for the last one, it's 35 over 40. Okay, guys, very nice. Excuse me. So for the last one, 8 times 5 gives us the 40 in the denominator. And so we do the same thing at the top. We times the 7 by 5 and we get 35. So it's all about multiplying the top and the bottom by the same value in order to get our answers. So Nompumelelo, I'm not too sure what you would have divided. I'm just trying to think here. I mean, I suppose you can work with some like fraction number from 96 to 40, but that does make life a little bit more complicated. It's not wrong, but it does make life a little bit more complicated. So we always try and make our lives easy to see if we can times by whole numbers. Right. I don't know what I was going to say, sorry. I'm going to make it a smaller screen, Nana, so that you can take a screenshot of all of them. But I'd like you guys, I haven't put a C here, but I'd like you guys to try C for me. So there's 5 fractions here. I've given you the first one. I want the equivalent fractions that I've listed there. Remember, again, they're all equal, all equivalent, must represent exactly the same proportion of the whole. So have a think, do it carefully. Think about what you need to times either the numerator or denominator by to get the answer that's there or the value that's there. We're going to have a look when you're done. Nice, guys. I'm seeing hands. I'm not seeing any answers on the chat yet. So I'm assuming we're still getting there. Walker, the next one is up on the screen, 6/7. And then there's 4 fractions we're wanting to work with. So it is there. Have a look. So Nompumelelo, you can continue with the same fraction if you want to, and that's why I'm saying you'll just get a weird fraction going on, but you don't have to, because all of the fractions are exactly the same. You can pick any fraction you want to work with, and so that's why I'm saying pick the one that's going to make your life easier. So it's not wrong to do it, but we could see that it would be easier to work with the first one, and because it represents exactly the same thing, let's just use it. Okay, we got lots of hands. Palesa Modipa, do you want to do the first one for us?
Yes, ma'am. So the first one is 12 over 14, and you're multiplying by 2.
Perfect. So 7 times 2 gives us that 14. So we do the same thing then in the numerator. Thank you, Palesa. Well done. Excuse me. Oh, just clicking things. It's going mad. Alrighty, Jose, do you want to give us the third fraction or the second fraction, what that's missing?
Ma'am, the third one will be 18 over 21, ma'am.
Perfect. 6 times 3 gives us 18, so we need to times 7 by 3 in order to get that 21. Very nicely done. Well done. Okay. Oh, golly. Sorry, guys. It just doesn't want to work for me. Let's have a look. There's so many hands. It's wonderful. I know your name isn't Rose because I know you put it on the chat to change it. So just remind me of what your name is and then help me with the next fraction.
Oh, hi, ma'am.
Hi.
My name is Bokang.
Thank you, Bokang.
Okay.
Yeah.
Oh, ma'am, for the third fraction, it's 30 over 35 because you times you say 6 times 5, and what you do on the top, you do on the bottom. So then you say 7 times 5 will give you 35.
Perfect. Well done. So guys, there you go. For the next one, 30 over 35 exactly has been explained to you. We times by 5 both top and bottom. Theo, last one.
Hello, ma'am.
Hi.
So, ma'am, I said 49 divided by 7, which was right, ma'am.
Yeah.
Which is I got 7, which is
Okay.
I found the number it was multiplied by, so I multiplied 7 by 6.
Good.
Then I got 42.
Perfect. So guys, here for this last one, we're essentially timesing by 7, and Theo explained how he worked that out. And so we've got 42 over 49. And that explanation, in terms of how we work out at 7, that's sort of going back to Nompumelo's statement of division. If you aren't sure, divide the other way. So 49 divided by 7 is 7. So I know 7 times 7 is 49. So I've worked out what I should be multiplying by. Right, if your hand is up, I'm assuming you have a question. If not, please lower it. There are going to be more questions, so don't stress. I am doing this so that you can take a screenshot of everything. So Jose and Sako, you guys still have hands up. I'm assuming it's for questions. If it's not, please lower it. And Sako, do you have a question? Oh, no, okay, never mind. Okay, so you're asking to try another one. We definitely can. We're already halfway, so let's take a break and then we'll come back with fresh minds to try another one. All righty, I'm hoping you've all got your screenshots. We're going to take a break and then we're going to give this whole equivalent fraction idea another try. Okay, here is our brain break. You asked for a soccer joke. There it is. Enjoy it. Okay, so guys, look at the brain break there. What I want you to be really careful of is take note of where there's 2 pot plants or where there's 2 sets of leaves, etc., and be very, very careful of the operation. Okay, if you don't have the operation correct, you're going to get the wrong answer. Right, I really see some hands. Very nice, guys. Kanya, do you want to help me out with our brain break?
Hi, ma'am.
Hi.
The first one is 5 plus 5 plus 5, hence the 15.
Perfect. So 1 pot plant is 5. Kanya, what then is 2? Oh, no. You can unmute yourself. What then is 2 pot plants if 1 is 5?
Pardon?
How okay, sorry, my words were very bad. If one pot plant is 5, what is 2 pot plants?
It will mean that 2 pot plants will be 10.
Excellent, well done. So guys, now we know where we see these double pot plants. I'm working with 10. Very nice, Kanya, well done. Pamela, do you want to help us with another one?
Yes, I would, ma'am.
Okay.
The second one is 50 plus 50 times 2. It will give us 150.
So remember, we've just worked out that the 2 plants are each worth 10.
Oh, they worth 10.
Yes. And remember,
Okay,
guys, we want to do multiplication first.
let me try it again.
Okay. Right, so Camilo's trying it again. Very nice. Emmanuel, help me out.
Ma'am, for the sunflowers, ma'am, it's 6 times 6. And I don't want to spoil the other one, ma'am, but the
Okay,
sunflowers
so let's do the leaves first. What are the double leaves?
14.
Okay, so guys, double leaves are 14 because 10 times 14, which we have to do first, is 140. Then we add the 10 to get the 150. So Emmanuel,
Yes.
now you can spoil it.
Okay, ma'am, it's gonna be 6 times 6 plus 7 plus
Why
7.
is it 7?
Given, ma'am, because the leaves in the previous one, ma'am, are doubled, ma'am. But then with this one, it's just
Good.
giving us 43.
Perfect. So guys, we have to be careful there. Those leaves were doubled. So that means in the next one, it's only half. So as Emmanuel said there, perfect. 6 times 6, 36. 36 plus 7 is 43. Palesa, do you want to do the last one for us?
Yes, ma'am. The last one is 10 times 7, which is 70, plus 6, it's 76.
Perfect. And very important there, guys, you need to do it as Palesa did it, order of operations, BODMAS, best friend, you need to do your order of operations. So guys, careful with the leaves. If the double leaves are 14, the single leaves are 7. There weren't any decimals there. Sorry, I need to have a drink of water and a cough. Onati, do you have a question?
I wanted to ask why.
You muted yourself?
I just wanted to ask, why is 10 plus 10 times 14 equal 150?
Because remember, we have to do BODMAS. So we have to do the multiplication first, and then only we do the we do the addition. So 10
Okay.
times 14 is 140, and then only do we add the 10 to get 150.
Okay, thank you.
Good. Okay, so guys, I think where most of us are getting stuck is the leaves thing. So what you need to be very careful of, and I'm going to really like zoom in here, is if we zoom in on the leaves, look at the leaves, it's double. So in the second one, there are 2 small leaves, and then there's 2 big leaves. In the third and fourth one, there's only 1 small leaf and 1 big leaf. So this is half of the one before. So if the one before was 14, half of that is only 7. So we need to be careful when we've got doubles or triples or whatever, that we are working with the correct value. And exactly, guys, this is maths. This is solving an equation. This is understanding the values of different things. So just be mindful of that. Okay, I see Boka said you can't see the questions. If you need me to make them bigger, please remember to just ask. I'm more than happy to do that. I'll try and make sure it's very clear, but I do try and give you a hint at the start to look out for doubles, but I will make sure it's a bit clearer next time. And just remember to ask me to make it bigger. I'm more than happy to do that, okay? All right, guys, so let's carry on with some examples. You asked me for another equivalent fractions one, which I'm going to give you now. Whoopsie daisies, I'm going to get there eventually. So your equivalent fractions that I want you to try here, this I think is D, if I remember correctly. So try this one for me. There are your equivalent fractions. I'm wanting those missing values there. Have a think. Remember, whatever you do to the numerator or to the denominator, you have to do the same thing then to either the denominator or the numerator. We don't do that, we're not keeping the fractions equivalent, which is a problem. Okay, we're doing really nicely so far, it looks like. Look, we're on it, guys. Well done. Okay, Matthew, do you want to give us the first one?
Hello, ma'am.
Hi.
Ma'am, the first one, oh yeah, okay. The first one is 12 over 20.
Perfect. So guys, 12 over 20, we times 5 by 4. And so we also have to times 3 by 4. Excellent. Well done. Okay, I'm going to try make sure that I get to people who haven't had a chance yet. I'm going to do my absolute best. Oh, so many hands. Letu, do you want to help me with the next one?
Yes, ma'am.
Okay.
So first, I knew 27 divided by 3, that's 9. So then I realized that I'm at the bottom, I must do 5 times 9, which gave me 45.
Excellent. Well done. And again, guys, when you're feeling stuck, do it the other way. Do the division so that you know what you need to times by. 5 times 9 is 45. Excellent. Tell me the third one. Hi.
Okay, ma'am. So the last one, you multiply 3 by 11 to get 33.
Perfect. Right, so we multiply that by 11. Very nicely done. Okay, so guys, that is essentially what we're doing. We're looking for one number that we can multiply both top and bottom by to make the fractions equivalent to each other, to make the fractions equal each other. Right, take your screenshot if you need. I still see some hands. We are going to do more questions. So there will be chances for you to answer. Don't worry. And guys, I'm just trying to give everyone a chance. Mongiseni, do you have a question? There should be a pop-up to unmute yourself if you've got a question. Okay, you can type your question in the chat if you do have one, and we can hopefully help you there, okay? Okay, guys, very nice. Well done. So sort of leading on from this is, whilst it's all fine and well to have all of these equivalent fractions, in maths, we always like our answers to be in the simplest form, okay? That's what we want. And so we need to be able to simplify fractions. Like I say, it's because we want them in the simplest form. So when looking at simplifying fractions, we have to follow quite a similar thought process around what we just did for equivalent fractions. But, excuse me, we want to now ask ourselves, from 12 and 15, what number can I divide into both of them in order to make it simpler? So if I look at 12 and 15, I can divide both of those by 3. If I divide 12 by 3, I get 4. And if I divide 15 by 3, I get 5. Now, I can't divide 4 and 5 by any number again. There's no number that divides into both of them without a remainder. And so I have simplified my fraction. So in this case, when I want to simplify, I divide. I want to make it simpler. I know to multiply in the other one because I'm trying to get them the same. And often what that means is timesing by the same thing in order to make the fractions equivalent. Right, Palesa, question?
Ma'am, where did you get the 3 from?
Okay, so the 3 I got from asking myself, is there a number that I can divide into both 12 and 15? Because if I can divide it into both, it means I can make the numbers smaller and simpler to work with. And so the number that can divide into both 12 and 15 is 3.
Oh, thank you, ma'am.
Good. Sanako? Nope. Okay, so guys, try for me question B. I'm going to leave question A up so you can see what we did, but ask yourself in B, what can I divide 27 and 63 by? What is the same number I can divide into both of them without a remainder to try and make those numbers a bit smaller, a bit easier to work with? Okay, Leah, do you want to tell me? No, Leah left me. All right. Ortile?
Hi, ma'am.
Hi.
I think you divided by 9.
Excellent. Well done. So guys, if we divide 27 by 9, we get 3. And if we divide 63 by 9, we get, we get 7. And so we have simplified this to a much smaller set of numbers in my numerator and denominator, which means it's easier to work with. Now, Emmanuel has put in the chat there another way to think of this. If you're thinking about what to divide by, look for the highest common factor between your numerator and your denominator. We're looking for the biggest number that we can divide into both of them, hence the highest common factor. Right, so very nicely done for all of you getting the same answer. If your answer is different, you haven't simplified fully, and this is a good example to show you. If you had taken your 27 over 63 and you'd said, okay, I can divide both of them by 3, okay? 27 divided by 3 is 9, and 63 divided by 3 is 21. Now that is simple. No, let me say that again. That is simplified, but it is not fully simplified because both 9 and 21 I can divide by 3 again. And so I need to keep dividing until I can't divide anymore. And then only have I simplified my fraction fully. Now, guys, very importantly, it is important that the 3 is in the numerator and the 7 is in the denominator. If you swap it, it doesn't mean the same thing. So the numerator and the denominator have to be correct. Okay, I see some hands. I'm hoping those are questions. Tato, Tini, and okay, and Sasanda, Okukle. I'm hoping they're questions. Tini, Sasanda, question?
Hi, ma'am. Ma'am, I just wanted to ask that. So with us that divided it by 3 first, it's not incorrect, right? As long as we get to 3 over 7.
Exactly. It just means that you're going to do 2 steps of division, and that's absolutely fine.
Okay, thank you, ma'am.
Okay, so guys, if you did 2 steps of division, that's fine. As long as you simplify as fully as possible, no problems whatsoever. Okay. Right, so let's try question C over here. We've got 20 over 65. Again, I'll leave B up, and I will make this a bit smaller so you can screenshot all of them. Don't worry. Ask yourself, what number can you divide, or what is the highest common factor between 25 and 65? What is the biggest number you can divide into both? Zali, do you want to try this one?
Hello, ma'am.
Hi.
Hey, ma'am. Now I divided by 5. I divided 20 by 5 and 60 by 5.
Perfect. And what's 20 divided by 5?
20 divided by 5 is 4.
And 65 divided by 5?
65 divided by 5, ma'am, is 12.
Close? 13.
13.
Good. Well done. Excellent. So exactly as Nzali said here, guys, we can divide both 20 and 65 by 5, and we get 4 over 13. Now, what's quite nice, I'm just going to make this smaller in case you want to screenshot all of this. What's quite nice, guys, is that your calculator actually does this all for you. So if, for example, you've got the, let me just get this right. If you type in that 20 over 65, when you push equals, your calculator automatically gives you the simplified answer. So if you want to double check yourself, type it into your calculator and make sure that the fraction it gives you is the same as what you've got. Your calculator will always give you the most simplified answer. Right? Another thing that's quite useful, and Nompumelelo put it on the chat, I hope my calculator can do this, is if you want the factors of a number, so the numbers that can divide into a value, let's say, for example, 20, you type 20 on your calculator and you push equals, right? Then if you look above, let me just get this right. If you look above, like the commas there, it says fact, and it's in yellow. So if you now say shift fact, your calculator gives you the factors of 20. So 2 squared, remember, is 4. So 4 times 5 is 20. So your calculator actually does all of this stuff for you. And you'll learn it as you go along, and you'll figure this all out as you go. But your calculator will always give you the most simplified form of a fraction. Excuse me. I'm just making sure I'm not missing any questions in the chat. I think we're all sorted, I hope. If you do, obviously let me know. Tando, your hand is up. Do you have a question?
Yes, ma'am, I have a question. Ma'am, you said that on the calculator you can type in the sum as is. Ma'am, can you put it in a fraction like 27 over 63?
Yes, yeah.
So
You can either
3
yeah.
over 7.
Yeah, so let's do it. If I type 27 over 63 as a fraction rather than with division, when I push equals, my calculator still gives me the simplified form. You're just writing the division in a different way. So yeah.
Yes, ma'am.
Good.
Thank you.
Perfect. Okay, Deirdre, I see a hand.
Hi, ma'am.
Hi.
Ma'am, I was just wondering which setting you should have your calculator on.
Okay, so the setting of your calculator, I'm gonna try and do this as well as I can. If you push mode setup, your calculator should always be on comp. So you should push 1 and it would be in the normal setting. The next thing you want to check is that it's in degrees. So if you push shift mode, oh golly, maybe I should push shift mode setup, it gives you a much longer list. Now my degrees here is option 3, if I'm not mistaken. And so we make sure we're in degrees, and that is then the correct setting for your calculator. So comp and in degrees.
Okay, thank you, ma'am.
Okay, cool. Guys, I also thank you on the chat for helping me out with that question. Tembi, I'm hoping that makes sense. You have to divide by the same number at the top and the bottom. Remember, we spoke about that earlier.